Welcome to watch the video. Trajectory tracking and dynamic obstacle avoidance for reconfigurable cable-driven parallel robots with aerial and ground mobile bases. A cable-driven parallel robot, CDPR, with only ground mobile bases, GMBs, referred to as a CDPR GMB, has a limited workspace in terms of height. A CDPR with only aerial mobile bases, AMBs, referred to as a CDPR-AMB, cannot fully constrain the moving platform, leading to a limited capacity to withstand external wrenches. A CDPR with both aerial mobile bases and ground mobile bases, referred to as a CDPR-AGMB, can address these limitations. However, trajectory tracking is challenging for a CDPR-AGMB, and it is even more challenging to avoid obstacles, due to the multiple rigid and soft bodies. This letter develops a trajectory tracking planner based on optimization for a CDPR-AGMB, enabling the CDPR-AGMB to reconfigure and track a target trajectory. This letter further proposes an obstacle avoidance planner based on reinforcement learning, RL, for a CDPR-AGMB to avoid sudden obstacles in real time. This letter develops a CDPR-AGMB prototype with one aerial mobile base and 4 ground mobile bases. The trajectory tracking planner and obstacle avoidance planner are validated based on the CDPR-AGMB prototype. Please look at the left figure. The trajectory tracking planner and the obstacle avoidance planner are combined. The trajectory tracking planner will switch to the obstacle avoidance planner if the distance between the moving platform and an obstacle is less than the critical distance, and vice versa. The trajectory tracking planner determines target velocity for the aerial mobile base, ground mobile bases, and length variable cables to move the moving platform to waypoints based on solving an optimization problem. The obstacle avoidance planner determines target velocity for the aerial mobile base, ground mobile bases, and length variable cables to avoid an obstacle and move the moving platform to a waypoint not within the obstacle. The obstacle avoidance planner is achieved based on sim-to-real reinforcement learning. An obstacle avoidance planner is established based on the Soft Actor Critic SAC algorithm and trained in a MuJoCo simulator. It is shown that it is hard to achieve an effective obstacle avoidance planner according to the designed rewards directly. This letter proposes a 3-stage training strategy based on the reward shaping technique to address the challenging training task. The combination of the achieved obstacle avoidance planner and a trajectory tracking planner is applied to a CDPR-AGMB encountering obstacles that suddenly appear in the target trajectory in simulation. The CDPR-AGMB can go over a low obstacle. The CDPR-AGMB can track the target trajectory if it is away from an obstacle. The CDPR-AGMB can go over an obstacle with a medium height via lifting the moving platform by the aerial mobile base. The CDPR-AGMB can track the target trajectory if it is away from an obstacle. The CDPR-AGMB can bypass a high obstacle. The CDPR-AGMB can track the target trajectory if it is away from an obstacle. Let's test the obstacle avoidance planner and trajectory tracking planner in the real world. In the first test, a CDPR-AGMB is set to encounter a low obstacle that suddenly moves to and stops at the target trajectory. The CDPR-AGMB can track the target trajectory and go over the low obstacle without making the aerial mobile base rise too much. Once the CDPR-AGMB avoids the low obstacle, it can move back to and continue to track the target trajectory. In the second test, a CDPR-AGMB is set to encounter an obstacle with a medium height that suddenly moves to and stops at the target trajectory. The CDPR-AGMB can track the target trajectory and go over the obstacle with a medium height obstacle via lifting the moving platform by the aerial mobile base. Once the CDPR-AGMB avoids the obstacle with a medium height, it can move back to and continue to track the target trajectory. In the third test, a CDPR-AGMB is set to encounter a high obstacle that suddenly moves to and stops at the target trajectory. The obstacle is too high for the CDPRA-GMB to go over. The CDPRA-GMB can bypass the high obstacle and continue to track the target trajectory. Thank you for watching.